I have an inexperienced driver. They lose control of their vehicle. They drive off a cliff. That would be bad, right? So I'm going to make a little drawing. There's my cliff. Here's my car. And my car is going forward. So this is a lot like the first lab that we did, where you took a ball and you rolled it on the tabletop, right? So before before you leave the surface here, um, you're not a projectile yet, right? But as soon as you drive off that surface, then whatever velocity you had, that's going to be your initial velocity. And your initial velocity, remember, is all in the x direction. So whatever your velocity was on the surface, that'll end up being Vx. All right. So he loses control of his vehicle. He drives off a 277-meter high cliff. That is not going to end well. So the cliff is 277 meters high. That is going to be dy. All right. He is traveling at 31 meters per second. So Vx is going to be 31. Because whatever his velocity was, that's going to just, in the x direction, in the horizontal direction, that'll remain his velocity. All right, so now what we want to know is it says calculate the distance the car will be from the base of the cliff when it lands, and what's the car's final velocity. All right, so it's going to go, it'll follow a parabolic path, remember, hits the ground, and we want to know how far from the base of the cliff. That will be dx. And then we want to know the final velocity. That is the actual velocity, or it's the hypotenuse of the triangle that we keep making with VFY and VX. All right, so who's going to offer me a suggestion? Where should I start? What's the very first thing I should do? Okay, so someone said get the time. Remember I told you the very first thing you should do in these problems is get the time. We can get the time from the height. dy determines the time in air. So we're going to use dy equals VOYT plus 1/2 g t squared. Okay, now original velocity in the y direction. This is going to be 0. Because the car, when it leaves the cliff, remember I keep calling it the Wile E. Coyote moment. So for that one instant in time, the car hasn't started falling yet. All right, for just one brief instant. So the original velocity in the y direction, 0, that disappears. We know dy is 277. That'll equal 1/2 times 9.8 times t squared. You want to get t squared by itself, so you have to divide both sides by 4.9 because 1/2 times 9.8 is 4.9. So 277 divided by 4.9. Does anybody know what that is? I got it to be 56.5. Can someone confirm?
Yeah.
All right, so 56.5. Now that's times squared. We don't want times squared, so we have to take the square root of that. So I'm using my phone calculator. I'll turn it sideways. Hit the square root button. I got 7.5 seconds. Confirmation?
Yes.
Okay, good. All right, so now I know the time in air is 7.5 seconds. Well, right away I can find dx. Because remember, in the x direction I have one single equation. In the x direction I have Vx equals dx divided by t. Well, I already know Vx, and I already know t. So for Vx, it's 31. Time is going to be 7.5. You guys know to do this algebra, because this is on the bottom, you would have to multiply both sides. So dx, or the range, 31 times 7.5. I got it to be 232.5.
Yep.
Okay. So 232.5 meters. That's what I get to be dx. So that's how far he lands from the base of the cliff. All right, so I finished that part. Now I have to find the car's final velocity. Oh, so someone asked me what happened to time in VOYT. So this is a good question, you guys. Let me write this out over here. So I'm going to write it, and we might as well do this. I'm just going to plug everything in. Okay, so I have 277 equals 0 times time plus 1/2 times 9.8 times time squared. So, all right. So then everybody already realizes 0 times anything, that's just 0. So that's why it disappears. And 0 plus anything is just the anything. So I just end up with that. So that's why, like, I took this and I just crossed them both out. All right. But please, if you have questions, like I said, make sure that you ask, because I always get someone who doesn't understand why I skipped a step or whatever. Okay, so now that's dx. Now we're trying to find final velocity. So the final velocity is the speed and the angle that it's going to hit the ground at. All right. Now that we can break it up into its components. That's what we've been doing. So we've been breaking it up into VFY and VX. All right. So this is really what we want. We want this hypotenuse, and we want this angle. All right. But we can't. There's no way that we can directly calculate this. So we can directly calculate the components, and then we can work backwards, right? So we already know this side of the triangle. We know velocity in the x direction. That's going to be 31. Okay, that was given to us. What we need to figure out, final velocity in the y direction. Okay, now once we know time, that's not hard to find either, because we have an equation that says final velocity in the y equals original velocity in the y plus gravity times time. So final velocity in the y, that's going to equal 0 plus 9.8 times 7.5. Does anybody know what that is? It's like 74-ish.
73.5.
73.5. 73.5 meters per second. Okay, so that's going to be this part of the triangle. So now that I have the two sides of the triangle, this is very comfortable math for you guys. So we need to find the hypotenuse. So we'll do 73.5 squared plus 31 squared equals c squared. Square those, add them, take the square root. When someone has it, shout out the answer.
79.7. Oh, 0.8, sorry.
79.8. Awesome. All right. So see, the final speed is going to be 79.8. If I had my radar gun, that's what I would get as my reading. And then I need to find the angle, right, to get the velocity. You guys like sine the most. So we'll do the inverse sine of the opposite side, which is 73.5. Over the hypotenuse, which is 79.8. And I don't know, my guess and check will be like 70 degrees. What is it?
67.1.
67.1. Nice. I was pretty close with my guess and check. So then for the car's final velocity, here the answer would be final velocity is 79.8 meters per second at 67.1 degrees. Right there. So that's that answer. So does that, are there any questions about why I did any of that stuff, you guys? No? So remember in the cliff problems, there's a few things that we know. We always know that the original velocity in the y direction will be 0 because your original motion is always horizontal, all right? And then because I'm sorry, I got distracted. Because there's only like 1/2 of the parabola, the time, that's always going to be like the total time, all right? So someone asked me to do another problem. Let me do some of these first, and then I'll go back and circle around. So someone asked me to do number 5 on the ground-to-ground worksheet. We could do that. I did it in office hours with some of the people who are in here. So that's why I'll do it at the end, all right? And that way, if those people who already did it want to stick around, they can. If they want to, they can leave. Number 2, I have a hunter, and he's perched in a tree, 21 meters above the ground. So if you guys know anything about deer hunting, you know, you go up in a tree and you're in a tree stand. So that's probably what he's doing. So the hunter's sitting up here in a stand, right? And he's 21 meters above the ground. So what we're saying is that dy equals 21 meters. Okay? Now he fires an arrow horizontally with respect to the ground. So he's bow hunting. And then that arrow is going to hit the ground. All right. He strikes a fellow hunter in the big toe. Got very lucky. Didn't hurt him too bad, I guess. Now, the arrow hits the hunter at an angle of 63 degrees. So when I do my final velocity here, this angle is going to be 63 degrees. Okay. I want to know a few things. I want to know the initial velocity. Now, initial velocity, you guys, that's going to be Vx. Because remember, it says I fire it horizontally. All of the velocity will be in the x direction. I want to know the final velocity. Well, that's going to be the hypotenuse of that triangle we keep making with Vfy. So right there, that is the final velocity. And I want to know the exact distance between the hunter and the base of the tree. And so that is going to be dx. All right. So this problem is basically asking us to solve for almost anything that we could solve for. All right. So I'm going to ask the same question I did before, and I'm going to look for a different person to answer. What is the very first thing I should do?
Solve for time.
Solve for time. Thank you. So I need to solve for time, and I have the height. I'm going to use the height to solve for time. So dy equals voyt plus 1/2 gt squared. All right? Dy is 21, and that equals 0 times time plus 1/2 times 9.8 times time squared. Now 0 times anything, that's just going to cancel, right? Because it'll become 0, and 0 plus anything is the anything. So now 1/2 times 9.8, that's 4.9. We need to move it to this side. So we're going to divide both sides by 4.9. So t squared will be 21 divided by 4.9. I got that to be 4.3. Yep. I got confirmation of that, 4.3. Now I don't want t squared, I want t, so I have to take the square root. And so the actual time, I got it to be 2.1. 2.1 seconds. So that's how long it takes to go through the air and hit the ground. Okay? Now, with this problem, I don't know Vx, right? That's one of the things I'm trying to find. So if I don't know Vx and I don't know dx, time's not going to help me there. Solve for either one, right? Because I only have one equation in the x direction. that equation is Vx equals dx divided by t, right? I don't know two of the variables, so I can't go there yet. I'm going to have to find one of those before I could find the other. And this is how I'm going to have to do it. I have the hypotenuse, right? I have the final velocity of this. I know that final velocity, I could split it into its components of v fy and vx, because there's no way for me to solve for the hypotenuse. I have to solve for the components, right? But I do know something about this triangle. I know that angle is 63 degrees. I know that I can't find Vx, but with time, I can find Vfy. So I can find this side of the triangle. If I know this side of the triangle and I know the angle, I could use trig to find all the rest of the sides. So let's find Vfy. Vfy is going to equal Voy plus gravity times time. And Vfy then will equal 0 plus 9.8 times, and we found the time is 2.1 seconds. So then when I plug that in my calculator, I'm sure someone's going to beat me to it. They did. Nice. 20.6. 20.6 meters per second. All right. So now I know this side of the triangle. And if I know this side of the triangle and an angle, well, I could find any other side. So which side do you want to find first? Do you want to find Vx or Vf first? Anybody have a preference?
VF.
Vf? Okay. So to find Vf, you guys, I know this angle and I know the opposite side. I'm going to have to use sine. Because remember, sine of the angle is the opposite side over the hypotenuse, right? So then what I'm going to say is the sine of 63 degrees is equal to 20.6 divided by Vf, because Vf is the hypotenuse, right? Now, if you do a little bit of algebra in here, Vf is going to equal 20.6 divided by the sine of 63. I ran out of space, so I couldn't keep going down. Does anybody have an answer for that? Twenty-three point 23.1. Okay. All right. So the final velocity 23.1. So if I wanted to know the final velocity, you guys, I know that answer right now. It is 23.1 meters per second at 63 degrees. I was already given the 63 degrees, right? So really all I had to find was the speed. So now to find this third side, I could use the Pythagorean theorem or trig. Which would you guys rather? Whoever shouts out first, that's the way we'll do it. All right, nobody shouted out, so I'm going to use trig. So Vx, that's the adjacent side. So if I want to find Vx, here, hold on, I'm going to try to, do I have room to, no, crud. All right, so if I want to find Vx, I'm going to use cosine. Now remember that the cosine of the angle, that's the adjacent side over the hypotenuse. So the cosine of 63 degrees, that's going to equal Vx, because it is the adjacent side, divided by the hypotenuse, which is 23.1. I really kind of wrote that messily. So Vx, you guys, is going to end up being 23.1 times the cosine of 63. Plug that in your calculator, and can someone tell me what they get? $10.5.
Mr. V, I have a question.
Sure.
So how come when you did the algebra to make that equation for the cosine, it's 23.1 times the cosine 63, and then when you found VF, it was divided?
Okay. So here, let me go through that real quick. I'm going to make a new page. So for the first one, we had the cosine of 60. Let me get the numbers right. 63 equals Vx divided by 23.1. All right. Now, in algebra, you guys learned that if anything is on the bottom, if it's being divided, to get rid of it, you need to do the opposite. So the opposite would be multiplying, right? So I have one on the bottom, I have one on the top. It'll disappear on that side. And so Vx will end up being 23.1 times the cosine of 63. Now for the other problem, we had a different thing. So we had the sine of 63 was equal to, let me get the 20.6. Was equal to 20.6 divided by VF. So it was on the bottom. Now, if it's on the bottom, once again, you have to multiply it to get both sides. All right. So there's two different ways you could do this algebra. I could multiply it to move it over here, and then I would have to divide that to move it over here. The other way, which you guys are probably better at, is to think of this as a fraction. So think of sine of 63 as sine of 63 over 1, and then cross multiply. All right. If I cross multiply, I would get 20.6 equals VF times the sine of 63. Now, if I want to get the sine of 63 over here, you guys know if something is being multiplied, you would divide it, right? Those will disappear, and I have VF equals 20.6 over the sine of 63. So that's why in one case it was divided, in one case it was multiplied. Does that make sense?
So when the variables are in the bottom, you divide, and the variables on top, you multiply.
Well, it'll end up being that way, right? Because that's the way the algebra works out. Yep. So you guys, and once again, this is algebra. This isn't physics, right? So if you mess this up, the most it could set you back is you could get a 9 out of 10 on this problem, right? So if you mess up the algebra, you mess it up. It is what it is. So anyway, to get back to this real quick, it asked for what speed that I fired it at, didn't it? Yep, the initial velocity, which is Vx. So now we know that. It was 10.5. So we know the initial velocity, we know the final velocity. The very last thing we need to know is the distance. And we're given this one equation. So I'm gonna clone this page, you guys, because there's so much on here at this point. And someone asked me in office hours yesterday, they're like, how the heck are we supposed to show all this work? And the answer to that is I will make it so that there isn't so much to do for each problem. Okay? But you're right, it will be a lot of work to be shown. All right. So this is the only equation I have to find dx. I know Vx now, it's 10.5. I'm looking for dx, and I know the time is 2.1 seconds. This is meters per second. I didn't write it down. But time is on the bottom, so we need to multiply it. Oops, that's just seconds. I don't know why I wrote that. Okay, these will cancel, and dx is going to be 2.1 times 10.5. Does anybody know the answer to that? going to be like 22.05. So that's how far they were away. Good thing they weren't any closer. Arrow would have hit him in a different spot. So besides the algebra stuff, are there any other questions on this problem? No. Okay. So then what we're going to do is we're going to do a ground-to-ground problem now. Okay. And what I have here is I have a motorcycle stunt person, and they're going to jump a canyon. But they're going to jump from one side of the canyon to the other side of the canyon. This used to be a big thing when I was a kid. Evel Knievel, if you ever heard of them. People would try to do these stunts. And so they set up a ramp on each side of the canyon. Right? It says that they're identical ramps on each side. Now we know that this canyon is 65 meters wide. And we know that he was successful. That's good. The time in air is going to be 0.86 seconds. So he went up, 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 and then he came down, 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 down. All right. We want to find two things. We want to find the exact reading on his speedometer as it left the ramp, and we want to know the angle of the ramps. Okay. Now I need you to remember that when he takes off from here, that's going to be his starting velocity. And that starting velocity is going to be exactly the same as his ending velocity on the other side. So whatever his initial velocity is, his final velocity will be the same. Now that's his speed. Remember, velocity is his speed, so that would be his speedometer reading. And it would be the angle of the ramp. All right, so basically what this question is asking us for, it's saying find VF. Now the reason that we're going to do it as VF, if you guys remember, is because we are going to take this and we're going to split it, right down the middle. And we're going to pretend that it's a cliff problem. So we're going to pretend in the y direction, only in the y direction, we're going to pretend that it started at the very peak and ended down here. All right, so we're starting here and ending here. So in the y direction, you guys, we're always going to use half of this time, because that time represents the time that it took to go up, 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 hit this top spot for one moment. It's not falling and it's not rising, so the velocity in the y direction, 0. And then it went down, 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 hits the ground. Okay, so it took 0.43 seconds to go up. It took 0.43 seconds to go down. So in the y direction, we're only going to use 0.43 seconds. Does everyone understand that part? So I'm not hearing any objections. I'm hearing some yeses. I see some yeses, I should say. All right. So, but in the x direction, we have to use the whole time, because in the x direction, we're looking at the whole 65 meters. That's the whole trip from edge to edge. Okay. So in the x direction, we always have to use the whole time. Here, let's write that down. Oops. I would prefer just to be writing without that crazy thing again. All right. So this is for the x. I use that time for the x. And then the time for it just to reach the peak to hit the ground, that would be 0.43 seconds. And I use that always for the y. So these are only for ground-to-ground problems, right? Because we're going to try to pretend this ground-to-ground problem is a cliff problem in the y direction. All right, so, well, we know dx, so we can, and we know the time and error was already given to us, so we can figure out vx. We can do that right away. Why do we need that? Well, because if I have my final velocity, right, I can make a triangle of its components. So I could figure out what VFY is, and I could figure out what VX is. And if I remember, this is VX right there, and this is VFY on this side. So this would be VF. And VF and VO, they're the same. Leaves the ramp at the same speed it comes down. So if I could find this, and I could find this, then I can complete the triangle. I could find the hypotenuse, I'll know the final velocity, I'll know the angle. So remember, there's one equation, one single equation for Vx, it's dx over t. And so that would be 65 meters divided by 0.86. In the x direction, I always use the whole time. And that's going to give me what? $75.6. Nice. So this part of the triangle, you guys, we know 75.6. I'm going to move this triangle a little bit further away from the, oops. Oh, come on. Why does it keep doing that? All right. Just trying to give myself some space. All right. So I know Vx. I can find Vfy if I have time too. How do I find that? Well, Vfy equals Voy plus gravity times time. Remember, in the y direction, we're always going to use that half a time because we're pretending it starts here and ends here. If we pretend it starts here, the original velocity in the y direction will be 0. Then I have plus 9.8 times 0.43. So can someone tell me what that is? It'll be around like 4.1.
4.2.
Thank you, 4.2. So that'll be VFY here. So now, to find VF, you guys, we just have to solve for the triangle, right? So we'll do the Pythagorean theorem. 4.2 squared plus 75.6 squared equals c squared. Square those, add them, take the square root. That's going to be really close to 76.
It's 75.7.
75.7, thank you. So the final velocity is 75.7 meters per second. And the angle is going to be really shallow, right? Because this, compared to this, is pretty small. So the angle is going to be the inverse sine of the opposite side, 4.2, divided by the hypotenuse, 75.7. It's just going to be a couple degrees, if that.
I got 3.2.
Yep, that seems right. 3.2 degrees. So then, now we know the exact reading on the motorcycle speedometer. So the exact reading was 75.7 meters per second. That's, around 160 miles an hour. And they set the ramps to be at 3.2 degrees. So if they had set the ramp at a higher angle, the stunt driver could have been going slower. Right? But I don't know, maybe the stunt driver wanted to go super fast. So that's the reading on the motorcycle and the angle. Now hold on, I'm trying to find out what time it is, how much time we have. 10:34. All right, so let me do one more of these problems, you guys, and then I'm going to do number 5 off of the last homework. Right? That was the one that someone asked me to do. Wasn't it? I'm looking. Yeah, number 5. Okay. So let me do one more. Let's see. Let's see which one I want to do. We have a professional golfer. Oh, this is actually a lot like number 5, so we're going to skip this one. Let's do this one. So this one is different than number 5. I have a frustrated Leiden tennis star, and she launches a tennis ball with a velocity of 29 meters per second at an angle of 24 degrees. So basically, if I was going to do this with my vectors, like this might represent the initial velocity. Now, remember, it's going to go up, 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 hit the point where it's at its highest, where it's not falling, not rising anymore, and then a moment later, it will be falling. I made it seem like it rose a little bit more. Okay, and then it's going to hit the ground. Now this angle, okay, I'm sorry. So remember, this angle with respect to the ground is the same as this angle. Sorry, my drawings are not the best, you guys, but you kind of get it. So that angle's that angle. This velocity matches that velocity, all right? So what we want to know is we want to know the range and max height. So we want to know dx and we want to know dy because that's max height. And we're given that the starting velocity was 29 meters per second. That if that was 29, this is 29. And we're given the angle was 24 degrees. If that was 24, this is 24 because they're going to be symmetrical. Okay, so for this one, you guys, we have the hypotenuse of the triangle. We're going to have to figure out the components. So if I have the hypotenuse here, I'll make this bigger. So we'll have VFY, which we could calculate from the hypotenuse and the angle, and then we'll have VX. All right. Okay, so there's my triangle. We know that the hypotenuse is 29. And we know that this angle is 24. So this, we're going to have to use trig. We're going to have to use trig to find the opposite side. That's going to be VFY. And then we're going to have to use it to find the adjacent side. That will be VX. Well, actually, we could use the Pythagorean theorem to find one after we use trig to find the other. So, you guys seem to like sine better, so we'll find VFY first. So the sine of 24 degrees, remember that's going to equal the opposite side, which would be VFY, over the hypotenuse, which is 29. Now 29 is on the bottom of this equation, so we'd have to multiply both sides, and it cancels out. So VFY is going to be 29 times the sine of 24. Can someone give me the answer for that? Okay, so VFY is 11.8. And then to find Vx, we're going to use cosine. So Vx will end up being 29 times the cosine of 24, if we do that algebra. $26.5, thank you. So Vx is 26.5 meters per second. Now I have my triangle filled out in order to find dy and dx. So let's just think about this. Remember, we have one equation for velocity in the x direction. It's Vx equals dx over t, right? So we know Vx now, but we're missing two of these variables. So what's the very next step that we have to do? What do we have to find?
Time.
We have to find time. It always goes back to finding time, you guys. Now, we don't know the height, but we do know VFY. So if we know VFY, then we could use that to find time. So we'll use this equation, VFY equals VOY plus gravity times time. All right, oops. Okay, so VFY, that's 11.8 equals 0 plus 9.8 times time. So the 0 is just going to go away. And to find time, we're going to divide both sides by 9.8. Right? So 11.8 divided by 9.8, it's going to be like 1.2, 1.3. Okay. Now, remember that this time, you guys, sorry, is only half of the time. And because in the y direction, we keep pretending that it's starting here and ending here. So the time that we found, we use this as the starting velocity in the y direction is 0. The time that we found only represents from the highest point to the bottom. So we only found the time to get from here to here. So this would be half of the time for the total trip, which means that if we wanted to find the time from all the way at the bottom all the way over here, I would have to double it. It would be 2.4 seconds. Okay, so anytime we're looking in the y direction, we're only finding half of the time, or we're only using half of the time. In the x direction, we have to use the whole time, because the x is from the very beginning, up, 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 down, 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 right? Whole trip. So I could find this right now for Vx or for dx. Dx is going to be Vx, which is 26.5 times 2.4. All I did is I did some algebra here, right? You guys know how to do that algebra. So the range, dx, will be what? 26.5 times 2.4? No, it's times. So it should be something like 56.6. Because I think I was given an answer, but I think that was 26.5 times 1.2. 63.6? That seems right. 63.6 meters. So that is the range. That's how far it ends up away. Okay, and remember, we have to use, in the x direction, we have to use this whole time. Now in the y direction, we're only going to use this half a time. So dy, remember the equation for dy is VOY times t plus 1/2 gt squared. Remember, this is going to be 0, so I'm not even going to bother writing this down right now. That's just going to disappear. So dy equals 1/2 times 9.8 times 1.2 squared. Can someone tell me what that is? going to be around 12-ish is my guess and check. Or did I overestimate that? Oh, I way overestimated it. I got it to be 7. Someone has 4.2. Can someone confirm this? I got 7. I got 7.0. Yep.
Yeah, I got 7 too.
Okay, awesome. So then distance in the y direction, 7 meters. And then we already know distance in the x, that was 63.6. So you guys, once again, it is really easy to make calculation errors here, right? Don't get too frustrated by that. Don't get too upset, because it's the process of getting to the answer that's more important to me than the answer, all right? Remember, you do all this work, and you write down some like 194 meters, you still get an A on this problem. Okay, so the numerical part, the typing it in your calculator, we're all human, we all make mistakes, so that is not going to seriously affect your grade, as long as you have the meat of the problem, right? The problem solving. So at this point, I'm going to do the last problem. I'm going to do, or not the last, I'm going to do problem number 5 on the ground to ground sheet. So if you already did that in office hours yesterday and you want to bug out, feel free. If you want to stick around and see it, feel free to do that too. Okay?
Mr. V,
Yeah.
can you show me real quick how to plug in into the phone calculator that when you have, say, for example, like VF, when you have two numbers, when you're dividing, when you're doing trig, like 29 divided by 2, the cosine of 63. Remember that one type that we're going
Right.
over the next one?
So probably what you're going to have to do, Ollie, to make sure that it doesn't mess up, is you're going to have to you're going to actually have to do cosine of, here, let's go back. You're going to have to type in your calculator, like sine 63, enter. Get the answer, write it down. And then you'll have to, clear it all out and then do 20.6 divided by whatever that answer was. Because if you do it any other way on your phone calculator, the odds of it coming out wrong are very high. Because your phone, yeah.
Just turn the 63 first and then divided by the number.
Right.
Okay.
Yeah. It's not a satisfactory answer, but because it doesn't have the parentheses, like, there's just not a good way to do it. And that's why I think I told you guys, I just get one of those solar calculators, whatever they're called, like TI-35s or whatever, $10 at Walgreens, and it has the parentheses, it has all that stuff. That's what I just use, usually. I don't even have it here, it's at school. So not even I can use it. All right, so let's do number 5, ground to ground. Okay. So I'm going to take a screenshot of this. Oops. All right, so once again, if you guys need to, you can bug out, and then but I'm going to do this problem for whoever wants to see it. Okay. So I have a soccer player, and they're taking a shot on goal from 25 yards out. Now, there's a tricky part to this problem. Okay. And the tricky part is realizing that this 25 yards, that's actually only half of the total range. Okay? Because when they shoot it, they're going to shoot this ball. It's going to go up, up, up. This is the path it's going to follow. And it just barely misses the top of the goal. So they shot it just high. It says that it grazes the top of the crossbar at the peak of its flight. So that's the peak of its flight, and then it comes back down and it hits the ground. All right. So this height, the distance in the y direction, is going to be 8 feet. So dy equals 8 feet. And then the entire range is going to be 50 yards. If you got it to be 25, you just missed that part. You missed that it was going up, just went over the goal, and then came back down. All right? So I have a range of 50 yards. I have a height of 8 feet. Now, we can convert that. We know how to do factor label, but quite frankly, we don't have time. So 8 feet to meters, I'm just going to type it in Google. It's 2.4 meters, all right? So instead of using 8 feet, I'm going to use distance in the y, the max height, as 2.4 meters. So dy equals 2.4 meters. And then we're going to do the same thing with this 50 yards. So 50 yards, 2 meters. 45.7. All right. So dx is going to be 45.7 meters. And that's dx. So I know dx and I know dy. I want to calculate the velocity, which is the speed it leaves its foot and the launch angle, right? So basically what I want to do is I want to find the hypotenuse of the triangle, either when he launches it or when it comes back down, because remember, those are the same. Okay, so I'm looking for VF, because VF and VO, they're going to be exactly the same amount. Okay. Now, I can't calculate VF directly, but I can calculate VFY, and I can calculate VX. And from that, I can find the hypotenuse. So I can find the components. I can find the final velocity in the y direction. I can find the velocity in the x direction. And from that, I can calculate VF. Okay? So in these problems, what is the very first thing that you should do? Especially if you have either the height or the final velocity in the y, you have to get the time. That's right. So you always find time first. So we're going to use dy equals VOYT plus 1/2 GT squared, because the height determines the time in air. Now remember, because we're working in the y direction, that when we find time, it's only going to be the time for half of the trip, because we're pretending that the soccer ball is starting at its highest point and falling down and hitting the ground. So dy is 2.4. VOY is 0, so we have 0 times time plus 1/2, 9.8 time squared. Now this is going to disappear. So the time squared is going to equal 2.4 divided by 4.9. Does anybody know what that is? It's going to be really close to half. Uh, 0.49. And then I have to take the square root of that. So when I take the square root, then it equals I got it to be 0.7. Oh yeah, of course. It has to be 0.7. All right, so the time that it takes to get from this point, the highest point, to the bottom, that's going to be 0.49. or 0.7, I'm sorry. So that means the time it takes to get from the very beginning to go up to the highest point and come back down, that has to be 1.4. So I always use this for the y-axis or the y direction. I always use this for the x. Okay, so now that I have the time, I can figure out Vx. I can do that because I have dx already. So Vx, that's going to be dx over t. Vx is going to be 45.7 divided by, I have to use the whole time, 1.4. And so 45.7 divided by 1.4. Anybody have that? I got 32.6. Okay, yeah. Someone confirm that with me. So 32.6. So I know this side of the triangle. And then to find this side of the triangle, that's VFY. That's equal to the original velocity in the y direction. We're pretending it started here, so that'll be 0. Plus 1/2 gt squared. And remember, we're pretending it started here, so we can only use half of the total time. So VFY equals 0 plus 1/2 times 9.8, and then half of the total time would be 0.7. Oh, wait, you guys, I wrote down the wrong equation. Nobody stopped me. It's just GT. I'm already getting tired. It's just VOY plus gravity times time. So 9.8 times 0.7. Remember, because this is the time from here to here. So 9.8 times 0.7. It's going to be like 6.8, 6.86. I'm just going to say 6.9. So now I know this part of the triangle. And you get, I think everybody knows how to find the hypotenuse from this point. So it's a squared plus b squared equals c squared. And then to find the angle, you're going to do the inverse sine. Do you want to go through that as a group? Or is everybody good ending it here?